In this video, we're going to prove that whenever you have log base a of x, take away log base a of y, it's simply x divided by y. And we've used this many times already, but now in this video we're going to prove this. And the way we go about proving this is that we rewrite this number x here as something to the power of another thing. So rewrite this number here, this number x here, as this, and then rewrite this number here, rewrite this number y here as a number to the power of something. And remember, we can always write any number as one thing to the power of another thing, because if you look at the graph y equals 2 to the power of x here. Let's say you've got a number z here. You can always rewrite this number z as 2 to the power of something, because you can see that it exists right here. Okay? Or if you have let's say y equals 3 to the power of x here. If you have a number z anywhere, let's say here, then you can always express the number z as 3 to the power of something. It does exist. My point is that given any positive number, given any number greater than 0, you can always rewrite it as this number here. Given this number here, any number, if it's bigger than 0, you can always rewrite it as this number here. So later on, we're going to put this into here, and then put this into here. But let's just translate this. So when given this here, we can always translate it to log base a of x gives us m. So whenever we have this, we can always translate it to this. We've done several exercises on this, and when given this here, we can always translate it back to here. Because if you look at this now, just looking at this here, when you look at this, your eyes will zoom into the a. So you should say to yourself, a to the power of what will give us this thing here. And then if you look at this, a to the power of what, but the what in this case is the m. And look, me from here translated it to this. And look at this, this is exactly the same as this. So my point is that when you are here, you can always translate it to, you can always translate it to log base a of x equals m. And when given this here, you can always translate it to log base a of y gives us n. Okay, so when you get given this, you will automatically get this. When you get given this, you will automatically get this. Okay, so remember, m, later on I'm going to ask you to replace m with this, and then later I'm going to ask you to replace n with this. Well, anyway, when given this here, you can always we're trying to prove this here. So the way we're going to do is we're going to rewrite this number here as a to the power of something. We're going to rewrite this as a to the power of another thing. So looking at this here, okay, looking at that here, looking at that there, you see, looking at this at the moment, it is x over y. So let's write x over y. Look at this. When you get x divided by y, you're going to get this divided by this. So therefore this must be true. Okay, because whenever you have x divided by y, then you can say that this can divided by this. So with this here, we can jump to this. Okay. So now using our laws of indices, whenever you have this divided by this, it's simply m take away n. Okay, so from here, this is the same as this. Okay, and then you log, and this is a trick here. You deliberately log to the base a to both sides, because later on it will cancel out with this. But let's log base a to both sides. So that would give us, so from here, log base a this will give us this. Log base a this will give us this here. Okay, and using one of the laws which we've already proved, whenever you log a to the power of something, then this something gets moved out to here. So basically we've already proved this. So we are logging a to the power of this bubble here. So we can actually move the bubble out here. So this thing here will then become this thing here. Okay. And we've done several videos on this. If you have a to the power of something, if you log it, then this thing here gets moved out here, and then it will be that bubble log and then a. And we've done many examples on this. Okay. Well, anyway, so from here we will get to here. Okay. And looking at this here, at the moment you've got one thing multiplying with another thing. But looking at this block here, if you translate this, your eyes should zoom into this. A to the power of what will give us this thing here? Will give us a. Well, it can only be one. A. So whenever you log something, you're really looking at the index. You're looking for the answer in terms of the index. So this log base a of a is really 1. It equals 1. So this block here is 1. So then that means you've got this times 1. So this times 1 equals this. So basically this is the same as that. Okay. So now yeah. So now you've got this thing equals this thing here. Now earlier, remember this bit here. Okay. Earlier we worked out m as, see this, remember this, whenever you have this we will automatically get this. Whenever you have this you will automatically get this. Now m equals this and n equals this thing here. So let's scroll down and earlier we had well, m equals this and n equals this. So let's substitute those two into the equation here. Then that will then give you this. Okay, m, we substituted it, and then n here is this thing here. So now we've got, basically we've just pretty much proved it, because here whenever you have log base a of x and then take away log base a of y, then it's simply this. So when we get to this stage here, it is what we set out to prove, which was this thing here. Okay, so this is exactly the same as what was down here. Hang on, there. Okay, and the secret in in proving this is just to rewrite this x here as something to the power of another thing, and rewrite this number here, this number y here, as this, and then slowly work through it. Okay.